Well, welcome to 5.7. This is a section about rational exponents. First of all, let me remind you what it means to be a rational number. A rational number is anything that can be written as a fraction. So if you have a over b, that's a rational number. 2/3 is a rational number. 1/5 is a rational number. 6 is a rational number because you can write it as the fraction 6 over 1. So dealing with rational exponents, though. So we're talking about fractions in the exponent. For example, something like that. Well, let me show you this. Would you agree that the square root of x times the square root of x is equal to x? That's what that means, right? The square root of a number is the number that when you multiply it by itself, you get that number. So, for example, the square root of 9 times the square root of 9 is, of course, 9. Because square root of 9 is 3 times 3, and 3 times 3 is 9. Well, if you remember some old Algebra 1 stuff, remember when you have, like, for example, x squared times x to the 3rd power, the answer becomes x to the 5th power? And the reason being is that x squared means x times x, and x cubed means x times x times x. Well, look how many you have. 1, 2, 3, 4, 5. So the shortcut is when you multiply numbers that have the same base, you add their exponents. Seems kind of weird, but that's what happens. So in this case, look what happens. X to the 1/2 times x to the 1/2. Well, add 1/2 and 1/2 and you get 1. So x to the 1/2 times x to the 1/2 also equals x. So does it make sense then that these two things are the same thing? If these two things add up to x and these two things add up to x, maybe these two things are the exact same thing. And as it turns out, that's the definition. Square root of x is equal to x to the 1/2 power. Now, more generically, the nth root, listen to how I said that, the nth root of x is equal to x to the 1 over n power. This number in here is called the index. Usually when we have a square root, you don't write it, but there's a little invisible 2 there. So when I take a square root of a number, that 2 could be put into the denominator of a rational exponent. So let me remind you a little bit about taking different roots where the index is a different number. This is a cubed root. Cubed root is a number that multiplies by itself 3 times. So what multiplies by itself 3 times to give you 8 is 2, because 2 to the 3rd power is 8, and the cubed root of that would be 2. Similarly, 4th root of 16. Now notice how I said this one. This was cubed root, but after that we just call them by the number. 4th root, 5th root, 6th root, so on. So the 4th root of 16, what multiplies by itself 4 times and gives you 16? Well, that's 2, because 2 times 2 times 2 times 2, 2, 4, 8, 16. Cubed root of 125 is 5. So it's helpful if you kind of have a feel for some of the different powers of numbers, knowing, for example, that 4 to the 3rd power was 64, which means the cubed root of 64 would be 4. So if I gave you the 5th root of y, you should be able to recognize that that would be y to the 1/5 power. Cubed root of 25 could be written as 25 to the 1/3 power. Or, and sometimes there's an advantage to doing this, if I took the cubed root of 25 and rethought of 25 as 5 squared, well, 5 squared now, just like I did here, right? I'm raising it to the 1/3 power, so I'm taking 5 squared and raising it to the 1/3 power. Now, let me remind you of something here. If you have x squared raised to the 3rd power, you don't add these exponents. In this case, you multiply them. Let me show you why. Because raising something to the 3rd power means you multiply it by itself 3 times. And so when you multiply numbers that have the same base, you add their exponents. So 2 plus 2 plus 2, that gets you 6. So when I have this, what I call power raised to a power, you multiply the exponents. like I did over here. But in this case, I have 2 times 1/3. I'm going to write 2 as a fraction, and so you get 2 1/3. So if the question was, write this with rational exponents, that would be the answer. In a most simplified form, this would also be the answer, but this is just kind of a nicer version of that. Another example, I would start you off here. Or the question I guess would be simplify or find 8 to the 2/3 power. Well, I'm going to take the root first. I'm going to take the cubed root. When I raise 8 to the 1/3 power, I'm taking the cubed root of it. So cubed root of 8 is 2, right? Because 8 is 2 to the 3rd power, and then that's being raised to the 1/3 power, and then that's being raised to the 2nd power. When you multiply these exponents, you just get 1, and then still squared, and you end up with 4. So what I'm doing is I'm taking the cubed root of 8, that's 2, and then I'm taking 2 and I'm squaring it and getting 4. Pause the video for a second and try this one, see if you can come up with an answer. I'm going to take the 4th root of 16 first. Well, the 4th root of 16 is 2, and then I'm going to raise 2 to the 3rd power and get 8. This is a good skill to have. I will ask you a question just like this on a test or a quiz. Different variation, different sample to try here, or example rather. Just simply multiplying numbers and with rational exponents. So x to the 1/5, x to the 7/5. When you multiply numbers that have the same base, you simply add their exponents up. So 1/5 plus 7/5 gets you 8/5. And it would be okay if you left it like that. It depends on what the question is. If it says to write it as a radical, well, now what I have to do is think of this as the 5th root of x to the 8th power. Well, hold on a second. X to the 8th power, that's x to the 5th power times x to the 3rd power. Remember, you add the exponents. But the 5th root of x to the 5th, that is just x. And then the 5th root of x to the 3rd, well, I can't simplify that one. So this would be the answer if the question said write it in radical form. This would be the answer if it said write it in rational exponent form. Remember what the negative does. A negative ends up putting the fraction or the base in the denominator. So y to the negative 3/4 would be the same as 1 over y to the positive 3/4. Now remember, this is a radical, so I'm going to rationalize that denominator. Now remember, the idea is you want the denominator to not be a radical anymore, so I'm going to multiply it by the number 1, but I only need to get this to be not a fraction anymore. And so 1/4, when I multiply y to the 3/4 times y to the 1/4, I'm going to get y to the 4/4, which is just y. And now I've y to the 1st, and now I've rationalized to the denominator. The numerator, of course, you just multiply and you get y to the 1/4 up there. That one's a little trickier. Play around with that and check with me if you have some questions. This question is just to simplify if possible. So what I've done is I'm taking a 4th root, so I raised it to the 1/4 power. Now each of these, I rewrote the 9 as 3 squared, and then each of these are now being raised to the 2nd power. So instead of having it as 2 separate ones raised to the 2nd power, let's just have it as 3z raised to the 2nd power. Well, when you have a power raised to a power, these guys multiply, and 2 times a 4th is 1/2. And raising something to the 1/2 means the same thing as taking the square root of it. So in a simplified version, the 4th root of 9z squared is just the square root of 3z. These are a little tricky. Ask some questions. Let me help you out. Let me know what I can do to get you over the hump.